So we're solving rational equations, and we've got this problem right here. That is not very good ink. Let's see if we can get a better one, huh? Let's see. Boy, that's not very much better, is it? What is the deal with that? So a brand new box. Could be trouble. Could be trouble in the neighborhood. Let's see. Okay, so what do we need to know to be able to solve this? Well, what we have to do is we have to multiply by whatever the denominator is. Okay, so when I multiply this side by the denominator, well, I wish I had a pen that had ink that would work. Huh? When I multiply this side by the denominator, I get 2x plus 1 times the fraction that we have here, x plus 2, 2x plus 1. And on this side, I've got 1 times 2x plus 1. Well, that's easy, huh? So this one's easy too, because if you have the same thing on the top as you do on the bottom, then they cancel out. So what we end up with is x plus 2 equals 2x plus 1. I need to subtract my x, and then I need to subtract my 1, and I get x equals 1. So 1 is the number that makes this true. So let's see. 1 plus 2, that's 3. 1 times 2 is 2 plus 1, that's 3. 3 divided by 3 equals 1. Hey, 1's the answer. We did it. We solved the equation. And how did we do it? We multiplied by the denominator. Let's see if we have better luck with this juice on this one, huh? What if we had a big monster one like this? X over x plus 2, x minus 2, minus 2, plus 1 over x plus 2 equals 8 over x squared minus 4. Alrighty. Now I need to multiply by the denominator, but not just the denominator, the common denominator. So I need to multiply by the common denominator. Now in order to do that, I need to factor. So let's factor this guy. So I know when I factor this guy that it has two parts, x minus 2 and x plus 2, right? Well, oh, lo and behold, that's what these two are. So the common denominator is x minus 2 and x plus 2, because that's over here and that's also over here. That's the common denominator. So if I multiply everything by that, then I will have x times x minus 2 x plus 2 plus 1 times x minus 2 x plus 2 equals 8 times x minus 1, 2 x plus 2. Well, no, look, this cancels out. This. What's left on this side is just 8, right? Well, this one has an x plus 2. This one has an x minus 2. So that cancels out. And that cancels out. So what's over here? X times, that's x squared plus 2x, plus, what's over here? Just x minus 2 equals 8, right? Ha! Because when I multiply by the common denominator, that's what this one was, right? So that canceled totally out. The whole denominator's gone. All that's left is 8. So you can't solve this unless you make it equal 0. So that means you have x squared. 2 plus 1, that'd be 3x minus 2, and then I'm going to subtract 8 to move it over there, so that makes minus 10. Hooray! Now you can use the quadratic formula. And so when you use the quadratic formula, you get x equals negative 5 and x equals positive 2. All right, two answers. X equals negative 5, x equals positive 2. But we got a problem. It has to work in the original problem. So negative 5 works, there's no problem. Negative 5, and then I can put negative 5 here, that'd be negative 7 on the bottom. I can put negative 5 here, that'd be negative 3 on the bottom, right? And what's going on over here? Why can't I use this one? It's because it makes the denominator equal 0. If I plug 2 in, I have 2 divided by 0. That's impossible. So this is called an extraneous solution. So this might be a new word. Extraneous. Look at all those vowels together. Extraneous. I forgot my R. Well, let's do it over here. EXTR, extraneous solution. Which just means it's a solution to this question, but it's not a solution to the one we wanted because it doesn't work in the original problem. Has to work in the original problem. This doesn't. So there's only one answer. That answer is x equals negative 5. Yay! So you always check for extraneous solutions. Oops, I erased extraneous. Why did I do that? We'll write check for, see if I can spell it. There we go. E-O-U-S. All right. Check for extraneous solutions. That's our job. Let's do one more. 1, the whole number 1, plus 4 over x equals 5 over x squared. Ooh, how about that one? Isn't that a beauty? Sure enough. So we know that the way we solve this is we have to multiply by the common denominator. This is x squared. This is x, and if you make that into a fraction, that's 1, right? So x squared is the common denominator. Remember, all x squared is just 2x's, right? X times x, that's what x squared is. So if I multiply this first one times x squared, I get x squared. And if I multiply this second one times x squared, I get 4 times x squared, which is the same thing as x times x. And then over here, 5 divided by x squared times x squared, right? Well, those cancel out. So 5 equals, what's over here? One of these x's cancels with that, so that's 4x plus x squared. Well, remember, you can't solve quadratics unless it's equals 0, so I've got to subtract the 5. X squared plus 4x minus 5 equals 0. Now, we've got to find our two answers. What numbers make this work? Well, positive 1 or what would the other number be? Negative 5 again. Huh. Okay, check to see that it works. Does it make this bottom one equal 0? No. If I put 1 in there, I can divide by 1. I can divide by 1 squared. If I put negative 5 in there, I can divide by negative 5. I can divide by negative 5 squared. That'd be 25. Right? So these both work. I checked for extraneous solutions. This one has 2 answers. The one before it has 1. So what are we doing today? Solving rational equations. And how do we do it? We multiply by whatever the common denominator is. And how do we find that? Well, we have to factor. And when we're done, we must check for extraneous solutions. All right. You can do today's work. Bye.